Okay, so we just talked about what we mean by unions, intersections, and complements. Now how can we use those to, or can we come up with some rules that use those concepts? So look at this question. An oil prospecting firm plans to drill 2 exploratory wells. So they're going to drill 2 wells looking for oil. Past evidence is used to assess the possible outcomes. So they have 3 events listed here. Neither well produces oil or gas. So that's one possibility, that nothing good happens. B, exactly 1 well produces oil or gas. So they're looking for either oil or gas. They don't really care which it is. So they're saying either of these. And C, so exactly 1 does, not both of them, just one of them, but either one. And C, both wells produce oil or gas. And from past evidence, so how do we know what the probabilities are for these? Well, obviously, they're just guesses, first of all. It's not like we're tossing a coin and we say the coin is balanced, and so it's 50-50, 1/2 and 1/2. You don't really have any idea. Like if I asked you, what's the probability that you'll be successful, you'd have no way of knowing in terms of drilling wells and getting oil. You have no idea at all, and they don't exactly have any idea, but they can make a guess based on their past experience, what's happened in the past. So this is what their guess is, that the chance that neither well will give you what you're looking for is 80%, exactly 1 is 18%, and both of them is 2%. One thing that does have to be true, whatever they say here and here and here, one thing is that of course these have to add up to 100%. So that is logically necessary, but the actual numbers in here, it's just guessing, and they're guessing based on past experience. Okay, so that's called how to assign probabilities to the events, and they're doing it kind of guessing, but based on past experience. So now they say find the probability of A union B. First of all, what does A union B mean? It means that neither well produces any gas or exactly 1 of them. So they want you to find the probability of that. So remember that union is expressed in English with the word or, O-R. And then this one, the probability of B union C, means B or C. So that's this or this. Okay? So they want us to find those probabilities. Probability of A union B and the probability of B union C. So let's go back and look at the rules that they come up with and then see how they will be used here to get the answer. So, where is it? Okay, here. So calculating probabilities for unions and complements. The addition rule. So when we can write the event of interest in the form of a union, so suppose the event of interest is A union B, or a complement, or an intersection, there are some special probability rules that can simplify our calculations. The first rule deals with unions of events. So we have this rule here. The probability of A union B is the probability of A plus the probability of B minus the probability of A intersect B. So if we look at the picture, we can sort of see where that might come from. Now, just to tell you, this book is okay, but I can recommend a book which is a little bit clearer and gives you a little bit more justification for how to understand what's going on here. But anyway, this is fairly clear. So here's an event A. If it's an event, it has to be, what I said before, a subset of S. And another event B has to also be a subset of S. And here's A intersect B. And we want the probability of A union B. And this rule says what? That the probability of A union B is going to be the probability of A plus the probability of B minus the intersection. So why is it like that? So where is the probability of A? Well, it's basically A is here. Okay? So we have that. And then B is here. So if I say it's the probability of A plus the probability of B, what I've ended up doing is counting this part twice. Whatever is in here, I'm counting it twice, because I'm counting it once here when I say the probability of A, and then if I add the probability of B, that's all here. So I'd be counting this twice, but I shouldn't count it twice. So what's the solution? To subtract it once. So that's what they do here. So there are other ways to kind of explain this, but that's kind of visually you can see that. So this rule is for the probability of A union B. So what is it again? Probability of A plus the probability of B. But then since we counted the intersection twice, we should subtract it out once. So we can use that to help us calculate when we have to do probabilities of probability of A union B. Okay, now we have that. We saw before that idea of mutually exclusive events means that they can't happen together. And remember, they can happen together if they have something in common. That is, if they have some intersection. So if they don't have any intersection, though, that is, if they're mutually exclusive, then this term here is going to be 0, because this is going to be nothing. There's going to be nothing in common, so the probability of that will be 0. So if they are mutually exclusive, then this will be 0. So then we can just say that the rule just reverts to this. Okay, so if they're mutually exclusive, we don't need this term, actually. We can still have it, because it's going to be minus 0, so it won't matter. But we can just simplify it to just write it this way. So when they're mutually exclusive, we just can write that without the last term. Okay? All right, so we have that rule. And now another rule has to do with complements. So remember, where is that picture? Complement. Here. So you can see that the complement of A is everything outside of A. So together, A and the complement give us what together? It gives us all of S. Right? So, but remember that the probability of the whole S has to be 1. I don't know if we said that very clearly, but the probability of S has to be 1. So what we're saying is that the probability of A plus the probability of the complement of A equals the probability of S, but the probability of S equals 1. So the probability of A plus the probability of A complement equals 1. So the probability of A plus the probability of A complement equals 1, but we can certainly rewrite that. Just bring this term over here. So we write the probability of A complement equals 1 minus the probability of A. Okay, so we have that rule also. So we have this rule up here. It's called the addition rule. And we have a kind of special case of that here when they're mutually exclusive. And now we have one more rule, which is here. All right, now maybe these can help us with some of the calculations that we wanted to do. For example, here we wanted to find the probability of A union B. So we use the rule A union B. First of all, can we use this rule, the easier of the union B rule, A union B rule set? We can only use it if they're mutually exclusive. Are A and B mutually exclusive? Is this and this mutually exclusive? Can you get neither well produces oil or gas and exactly 1? Yeah, they're mutually exclusive. They don't both happen at the same time, right? If none of them do, then you don't get exactly 1. So they are mutually exclusive. So if we want to calculate this, we can use this kind of simpler rule, which says that it's just the probability of A plus the probability of B. That's what they do. The probability of A plus the probability of B. That's 0.8 or 0.80 plus 0.18, which is 0.98. So the answer to this one is 0.98. And then this one, are these mutually exclusive? Can we say that? Exactly 1 and both. That's different, right? If you get exactly 1, then you didn't get both. And if you get both, you don't get exactly one. So they're mutually exclusive. So again, we can use that simplified rule. So we only have to add this plus that, so we get this. Okay, let's do one more. No, let's stop and I'll come back and do the next one.